So this is an NCRT problem number 5.32 for class 11th from the chapter of mechanics. Very interesting problem that helps you develop the concept of tension and how the area of normal reaction gets clarified using this numerical. A lot of students are confused on the direction of normal reaction, so on and so forth. So if you see this numerical very carefully, a lot of concepts on tension and normal reaction will come alive. Thank you very much. The video follows in a while. 5.32, okay? And if you have a different version of NCRT, don't worry. So the situation is that you have a man who is standing on this wall. So that's your place where the man is standing, okay? So this is a man standing here, and he is, holding, using his hands, a weight, okay? So this is a weight, and the weight is, some weight is given, okay? Maybe this is 25 kgs, and the mass of the man is given to be 50 kgs, okay? This is one situation where the man is trying to pull up. So he's trying to pull this mass up using his hands. So these are two hands, and he's trying to pull. The second is he gets a very simple machine, which is the pulley, okay? So that's your simple machine. And this time what man does is he invests, some money in the pulley, and this pulley then, is used by him. He connects this massless pulley to the wall, and then he runs a string which is going through the pulley and going then downwards, okay? And this, as it goes down, now the effort is different, okay? And let me just do some corrections in the diagram. He is actually, the man is standing somewhere here, okay? And the string is coming down, and this is where his hands are, okay? So the situation in the second case is that the man in fact is pulling the mass like this. So this is where the man is. He is still standing, but he's pulling on, and the mass is down, okay? So these two situations are same. I think this is more clear as a diagram. The question is, what is the difference, between the two situations? How do you distinguish between the two situations? Now, if you were to look into this, obviously the first thing that should strike you, and when you start thinking about tension, see, whatever tension is felt in the string, the tension that is felt in the string, if you see my previous video, this tension is by virtue of the weight which is connected to the end of the string. So if you look into this diagram, you would realize that the tension which is in this string, it will be equal to 25 times 10 is equal to 250 newtons. And even in this case, the second case where the man is pulling the string upwards, the tension, remains 25 into 10 is equal to 250 Newton, okay? Now, what is then the difference, okay? Now, if you look into the situation number one, which is this, the normal reaction, from the wall is this. So this is a normal reaction. The weight of the man himself is acting downwards is this. Okay, so this is mg, where m is for the man, and this is a normal reaction which I've shown. And then the man also, is experiencing a downward, force, that is, some tension. Although he's pulling it, but he's experiencing a tension downwards. So overall, if you see this man, there is a normal reaction coming from the ground. The earth is pulling, and the tension is also pulling him down. And the man is stationary, which means the normal reaction is being balanced by the weight of the man and the tension. Okay? So this is the case number 1. So if you look into the problem number 5.32 NCERT, what I've just discussed is case number 1. Let's go to case number 2. In the case of this situation, you again have a normal reaction. You definitely have the weight of the man, but this time around the tension, which in the case number 1 was pulling the man downward, as you can see. In this case, the tension is pulling the man in the upper direction. So this is where the tension is pulling. So you can see that this man has a normal reaction, a tension, and a weight which is downward. So the man is stationary. So tension plus normal reaction is equal to mg, where m is the mass of the man. So you can say this is a normal reaction in the second case. This is a normal reaction in the first case. The tension incidentally is same. So, but in the second case, you will get normal reaction is equal to T minus mg, where m is a mass of the man. So whatever mg is being referred to here is, and tension is because of the weight. Okay, so we can write this as mw and same as mw. So you can see the normal reaction here is T minus mg, and the normal reaction here is mg plus T. So when you do these questions, just be very careful that every possible concept is applied very carefully. And so you can see, application of a pulley, which changes the direction of tension. So you can see this pulley has the capability to change the direction, right? So earlier in this case, the case number 1, without the pulley, you were able to pick this up. But now what you have done is you have made the tension in a different direction in the case number 2, and therefore your normal reaction comes out to be much lesser. Okay? So hopefully you found this an interesting problem. Do small numericals where a lot of normal reaction and tension is asked for, and that will help you develop confidence in mechanics. A lot of students, are jittery in mechanics because of the, normal reaction issues and the fact that there is lack of clarity on tension in the string. I hope this helps you, and please continue to watch my videos, and if you like them, subscribe to my channel. My channel has 1,500 videos. These are, JEE and NEET numericals, and meant for students who are very serious to build a career. And you would find a lot of numericals that come in NEET and JEE are from my question bank. Thank you very much.